All right, everyone. Welcome back. Section 3.5.2. I'm saying point 2 because we're continuing our discussion about parallel lines. We are going to talk about slopes of parallel lines and also slopes of perpendicular lines. So let's take a look. Start with a quick review of slope of a line. This is something you would have learned in Algebra 1. So let's review it. Slope is the steepness of a line, the rise over the run. There's a formula to calculate slope. When given 2 points, x1, y1, and x2, y2, we have the slope formula, often designated with the letter lowercase m. Slope equals y2 minus y1 over x2 minus x1. So a little more about slope of a line. The slope is positive when a line is increasing and negative when a line is decreasing. On the left here, we see a graph where the line is increasing. Now remember, we always read a graph from left to right, just like we read words on a page. So when we read this graph left to right, you can see that it is increasing. So that line would have a positive slope. Well, the graph over here on the right, when we read it from left to right, that graph is decreasing. So that graph would have a negative slope. If we wanted to, we could calculate the slope of each of these. So real quick, over here we're given the 2 points, -1, -2, and 2, 2. So if we apply our slope formula, and let's see, I'll go over here, y2 minus y1 over x2 minus x1, and we simplify. So we would get -4 over -3. Well, of course, a negative divided by a negative is actually a positive slope of 4/3. So there's our positive slope for our increasing graph. Over here, we have 2 points, -4, 4, and 5, -2. So real quick, let's calculate our slope with slope formula. y2 minus y1 over x2 minus x1. So we get -6 over +9. That could be reduced to, let's see, -2/3. So there's our negative slope for our decreasing line. Now we cannot forget about slopes of vertical and horizontal lines. A horizontal line has a slope of 0. You can see our horizontal line on the left. A vertical line has no slope or an undefined slope. Now to understand this better, let's use our slope formula again. Over here we have 2 points, -3, 2, and 4, 2. So let's apply our slope formula. y2 minus y1 over x2 minus x1. And look what happens. On the numerator we get 0, in the denominator we get 7. Well, 0 divided by any number is 0. So that's why a horizontal line has a slope of 0. Now let's take a look at our vertical line. Here we have a point 1, 2 and a point 1, -4. So using our slope formula, we have y2 minus y1 over x2 minus x1. Well, look at what happens. Now we get 0 in the denominator. And you have to remember in math that you can never divide by 0, and that is why a vertical line has no slope. It's undefined. So we finally move on to the parallel slope property, and it states that in a coordinate plane, 2 distinct lines are parallel if and only if their slopes are equal or they are both vertical lines. And you can see in the diagram here, we have 2 parallel lines, and the slopes are being designated by the rise over the run. The slopes of both of these lines is 3/4. Next, we come to the perpendicular slope property, and it states that in a coordinate plane, 2 non-vertical lines are perpendicular if and only if their slopes are opposite reciprocals of each other. Now let's look at the diagram here. You can see the 2 red lines. They are perpendicular, designated by the right angle symbol right there. And let's examine their slopes. We're being told that the slope of this line is negative 4/3. Jumping ahead of myself. And the slope of this line is positive 3/4. Well, the two perpendicular lines have slopes that are opposite reciprocals. They are opposite in sign because this is negative and this is positive, and they are reciprocals. You remember that the reciprocal is when you flip the fraction. So 4/3 flipped is 3/4. All right, so let's take a look at an example of a type of question you might be asked. It says consider A, B, C, and D, and they give us the coordinates of all those points. Are line AB and line CD parallel, perpendicular, or neither? Well, we're going to answer this question by calculating the slopes of AB and CD. So let's go to it. Line AB, the slope of line AB. And I guess I shouldn't use M because that sort of means the measure of. So we'll just use AB equals y2 minus y1 over x2 minus x1. And here we're going to get 14, and here we're going to get 21, right? And that can be reduced to 2/3. All right, now let's compare that to the slope of CD. So here we have y2 minus y1 over x2 minus x1. And we're going to get 12 over negative 8. And that's going to reduce to negative, 3/2. So what's the relationship between the two slopes? Well, one is positive, one is negative, so they're opposite in signs. One is 2/3, the other is 3/2. These are opposite reciprocals of one another. Therefore, those lines are perpendicular. Let's look at one more. Given points E, F, and Q, find the coordinates of a point P such that PQ is parallel to EF. Well, this is a bit of a doozy. I like this one, a little bit more thinking than example A. So PQ is going to be parallel to EF. That means they have to have equal slopes. I know the coordinates for E and F, so I can calculate the slope of line EF. So let's start there. So I'm going to have y2 minus y1 over x2 minus x1. So I'm going to get negative 4 over 8, or negative 1/2. So now what this means is line PQ has to have a slope of negative 1/2 also. I know the coordinates for Q. I don't know the coordinates for P. So what I'm going to do here is I'm going to set up my slope formula. I'm going to call Q the second point. So when I calculate my slope, I'm going to have y2 minus y1, which I don't know. Then I'm going to have x2 minus x1, which I don't know. But I know that this slope has to equal negative 1/2. So, let's see, I could call this negative 1 over 2. And now I can solve the two equations. So on top, I have an equation, negative 2 minus y has to equal negative 1. So if I solve this, I can add 1 to the left side, so I'd have negative 2 plus 1, which is negative 1, and I would take the negative y over to the right side where it would become positive. So the y coordinate is negative 1. Then I have the bottom of my slope formula, which is a separate equation, and that has to equal positive 2. So now I would subtract 2 to the left side, so 4 minus 2 is 2, and I would take my negative x over to the right where it would become positive, so my x coordinate is 2. So the coordinates for P could be 2, negative 1. So there's a nice introduction to slopes of parallel and perpendicular lines and some of the types of problems that you'll need to be able to solve.